Somewhere between New York and London, there are 3,000 miles of open ocean, no islands to rest on, no shallow water to stand in, just water all the way down and then some. You've probably had the thought before, we've built bridges across bays, straits, even entire seas. So why has nobody just built one across the Atlantic? The answer you'll usually hear is it's too expensive, and sure, that's true, but that answer is kind of lazy because it skips the actual reason it's too expensive, which is far stranger than a big number. The real reason isn't really about money at all. It's about something much harder to solve with money. The ocean itself refuses to cooperate. Let's start with the most obvious problem, the one everybody guesses immediately: depth. The Atlantic isn't like the water under most bridges you've ever crossed. On average, it's about 12,000 feet deep. That's not a typo, 12,000 feet. And in the deepest section, a place called the Puerto Rico Trench, it drops to nearly 27,500 feet. For comparison, the deepest fixed drilling platforms humans have ever built into the ocean floor go down about 1,800 feet. We are talking about needing to go more than 10 times deeper than our deepest offshore structures, and doing it not once, but continuously, for thousands of miles. A bridge needs something solid to stand on. Every pillar, every tower, every cable has to eventually plant itself into the ground beneath the water. But at these depths, there's no standing. Engineers call it the difference between a fixed structure and a floating one. Past a certain depth, you can't build down to the seafloor anymore, you have to float. And floating changes everything. Here's where it gets interesting. Let's say we accept that floating is the only option. Engineers have actually built floating bridges before. There's one in Washington State, the Evergreen Point Bridge, that holds the record as the longest floating bridge on Earth. It's genuinely impressive. It's also about 2.5 miles long. The distance across the Atlantic at its narrowest reasonable crossing point is roughly 1,000 times longer than that. Not twice as long, not 10 times as long, 1,000 times. And floating bridges don't scale the way you'd hope. A pontoon bridge that works beautifully across a calm 2-mile bay starts falling apart conceptually the moment you stretch it across open ocean, because now it has to survive things a bay never has to deal with. Hurricane-force winds with nothing to block them, rogue waves that can reach over 80 feet, and constant relentless corrosion from salt water that never stops working on every joint, cable and seam you've built. So depth is problem number one. But even if you solved depth, you'd run straight into problem number two, and this one is almost never mentioned, the seafloor itself. You'd assume the bottom of the ocean is basically solid ground, just really far down. It's not. Large sections of the Atlantic seabed are covered in soft, shifting sediment, silt and mud that has been settling for millions of years. It's less like bedrock and more like the ocean floor is wearing a very thick, very unstable blanket. Try to anchor a support structure into that, and you're not building on solid ground. You're building on something closer to wet sand at the bottom of a pool that's 3 miles deep. And then there's problem number 3, which has nothing to do with engineering at all. It's traffic, not car traffic, ship traffic. The Atlantic isn't empty water waiting for us to build on it. It's one of the busiest shipping corridors on the entire planet, carrying an enormous share of global trade between North America and Europe every single day. Any structure spanning it would need to somehow not block, endanger or bottleneck that traffic. You'd either need impossibly tall clearance for the largest cargo ships on Earth to pass underneath, or you'd need shipping lanes to reroute around a fixed structure thousands of miles long. Neither of those is a small ask. Now let's talk about the number everyone jumps to first, cost. Because even acknowledging all of that, people still want to know, could we just throw enough money at it? Using the Evergreen Point Bridge as a baseline and scaling its cost up to Atlantic distances, rough estimates land somewhere in the hundreds of billions of dollars. And that's a generous best case estimate that doesn't fully account for the added cost of building at depths and in conditions no floating bridge has ever attempted. Realistically, you're looking at a project that could rival or exceed the most expensive infrastructure projects in human history for a piece of infrastructure that might not even survive its first major Atlantic storm system. So, depth, unstable seafloor, shipping lanes, and a cost that dwarfs almost anything ever built. Any one of these would make an Atlantic bridge extremely difficult. All four together make it, with current technology, essentially off the table. But here's the part most videos on this topic skip entirely, the part that makes this question actually more interesting than a flat no. If a bridge is off the table, what about a tunnel? You'd assume a tunnel avoids most of these problems, since it's underground instead of floating on top of the chaos. And you'd be partly right. A tunnel doesn't have to deal with waves, storms, or shipping lanes at all. But a tunnel introduces its own brutal problem: pressure. At the depths we're talking about, water pressure is immense, crushing enough that even reinforced materials struggle to hold their shape indefinitely. And a tunnel of this length would need to be sealed perfectly for the entire multi-thousand-mile length for decades without a single point of failure. One crack, one weak seam at that depth isn't a leak. It's an instant catastrophic collapse. There's also the smaller issue of what a multi-thousand-mile enclosed tunnel actually requires to function. Constant ventilation, drainage systems working non-stop against unimaginable pressure, emergency access points that would themselves need to be engineering marvels, and structural flexibility to survive extremely slow, extremely powerful tectonic shifts along the ocean floor over time. So neither a bridge nor a tunnel solves this, not because we lack the imagination, because the Atlantic is simply too deep, too wide, too geologically unstable, and too economically punishing for any crossing method we currently have. But here's the twist that most people never hear, and it's the part that actually changes the whole conversation. This exact idea has been seriously proposed before, just not across the Atlantic, across the Bering Strait. The Bering Strait separates Alaska from Russia by a little over 50 miles at its narrowest point, with an average depth of only around 165 feet, not 12,000. That's a completely different engineering problem. Shallow enough, narrow enough. And it's been proposed seriously, again and again, for over a century. In 1892, the same engineer who would go on to help design the Golden Gate Bridge proposed a Bering Strait railroad crossing. In 1905, Tsar Nicholas II of Russia actually approved a version of it. World War I and the Russian Revolution killed that attempt before it could begin. In the decades since, the idea has resurfaced again and again, from Cold War era proposals to a 2007 Russian government plan estimated at around $65 billion, to Chinese state media floating the idea of a high-speed rail tunnel as part of a broader intercontinental vision. None of these plans have ever broken ground, but notice what's different about every rejection. Nobody ever said a Bering Strait crossing was impossible. Every single objection was about cost, politics, or the fact that the surrounding region is so remote it might not justify the investment. Nobody has ever said the ocean itself makes this unbuildable, because at that width and that depth it isn't. That's the real answer hiding underneath this whole question. It was never actually, can humans build a crossing over open ocean? And we already know we can, at the right depth and the right distance. The real answer is that the Atlantic specifically pushes past every limit we currently know how to engineer around, all at once, in the worst possible combination. Too deep for a bridge, too deep for a tunnel, too unstable to anchor into, too busy to build across, and too expensive to justify, even if all of that were somehow solved. So the next time someone tells you we don't have a bridge across the Atlantic because it's just too expensive, you can tell them that's only a small part of the real story. It's not a lack of money, it's not a lack of ambition. It's an ocean that is, in almost every measurable way, actively hostile to the one thing we'd need it to do. Hold still long enough for us to build something across it. Maybe someday, materials get stronger, floating engineering gets bold enough, and costs come down far enough that this stops being fiction. But for now, the Atlantic remains one of the very few places on Earth that human engineering, for all its confidence, still has no real answer for.